Hello, can you hear me? Is the voice audible? Can you reply back in WhatsApp in our group? Can you hear me? Yeah, thank you. We will just hold on for a couple of minutes and then we shall start. All those who have joined in Teams, you can minimize the Teams and please click on that URL that I have given you. So Teams is just to record your attendance. I am not going to share any slides in Teams. I request everyone to please click on that link I have shared. We are just going to start in a couple of minutes. Okay, do not leave Teams. You can keep it minimized. Yeah, I will download the attendance maybe by the end. So please minimize Teams and then please look at what I am going to present now using the concept of what is called Kubernetes. Okay, so the topic for today is Kubernetes. Last class we have discussed something about Dockers and Docker applications. Today what we are going to discuss is the concept of Kubernetes. So to start with, you should understand what is Kubernetes and what purpose does it serve. If you talk of the concept of Kubernetes, Kubernetes is a container management system. Kubernetes is basically developed on the Google platform So what is the purpose of this called Kubernetes? This Kubernetes will be helpful in managing containerized applications. So this Kubernetes could be used in a variety of applications and types like physical environment, a virtual environment, or a cloud environment. Google Kubernetes gains importance because it is highly flexible. This is a container tool, okay, like the Dockers. And this Kubernetes will be helpful to consistently deliver complex applications running on clusters. And you should always remember, when I say it is a cluster, it could be hundreds to thousands of individual servers. So that is the power of Kubernetes, and as we progress, we will discuss about the architecture, then how a Kubernetes probably differentiates itself from a Docker, and then we will also see some pros and cons of Kubernetes today. So if you talk of the concept of a Kubernetes, so you can very well probably understand that a Kubernetes is basically responsible for managing clusters. So what is a cluster? A cluster is nothing but a group of servers, a series of servers, and they are all connected to run containers. So you should always understand the powerful feature of a Kubernetes is that a Kubernetes could probably scale up to 5,000 servers. Also, I'm introducing a new terminology which we will see later in the video. This Kubernetes has the capability to support about 150,000 pods in a single cluster. Pods is a new terminology introduced in Kubernetes, about which I will tell you what it is as we progress. To slightly give you a flavor of what a pod is, a pod is a group of containers that share resources. A pod is a network and it will be able to communicate with one another. So to put in simple terms, a pod is a group of containers that share some common resources. So this is what a Kubernetes could do. A Kubernetes has capability to support about 5,000 servers, within which it can probably have about 150,000 pods. Okay. Using these kind of features, what tasks can a Kubernetes accomplish? A Kubernetes is a Linux kernel. A Kubernetes operates on what is called the concept of distributed systems. Distributed computing entirely varies from what is called centralized computing. Distributed computing probably distributes the workload on different servers, and thereby distributed systems have a lot of advantages over centralized machines. This Kubernetes will offer a consistent interface for applications, and this Kubernetes purpose is, when I have a shared pool of resources, this Kubernetes will be responsible for using this shared pool of resources in a proper fashion. That is the basic task probably a Kubernetes could perform. The next obvious question is, why should I use a Kubernetes? A Kubernetes responsibility is resource allocation, then traffic management. As you might know, we have all moved to what is called microservices. So Kubernetes will be responsible for resource allocation and traffic management. This Kubernetes will also be helpful to simplify service-oriented infrastructures. And this Kubernetes will make sure I will be aware of where these containerized applications will run, and this concept will help me to find resources and tools that you probably would like to work with. So looking at some of the capabilities that a Kubernetes has to offer, what we are interested to look at is some of the features that a Kubernetes could offer. If you look at the features, we have something called automated scheduling. Then we have self-healing capabilities. Then Kubernetes are capable of automated rollouts and rollbacks. Kubernetes will be able to scale in a horizontal fashion, and they can also do a better load balancing. That is what I told you. When you talk of a Kubernetes has higher capability to probably manage the shared pool of resources, and that is where it will be able to do what is called load balancing. This will also probably serve as a consistent environment for development, testing, and production. Another important feature I would be interested in when I use a Kubernetes is, the infrastructure is loosely coupled. So whenever it is loosely coupled, automatically there is an advantage that gets added to it, where each component has a capability to act as separate units. And Kubernetes has some kind of enterprise ready features. It is auto scalable, and another important concept is it has something called the application centric management, and this feature obviously helps a Kubernetes in order to be adopted to a variety of applications in the real world. So before we move on into the architecture of a Kubernetes, we would like to introduce you to certain basic terminologies. To start with, we have something called a cluster. So what is a cluster? A cluster is a collection of hosts or servers. So what purpose does a cluster do? A cluster will help you to aggregate the available resources. So when I say resources that are all distributed, like the CPU power, the RAM, the disks, and the devices, the cluster has the capability to pool all the available resources together so that it will make it into something called a usable pool. The second one is called a master. A master is a collection of components that make up the control panel for Kubernetes. Master is a very important part in a Kubernetes. It's something like a control panel. And all kinds of cluster decisions will be controlled by the master. This includes scheduling and responding to any kind of an event that is basically triggered from a cluster. So master is something like a master unit that will be responsible for controlling the actions of the Kubernetes. Then the next probable terminology which you would be introduced to is called the node. What is a node? A node is a single host, a single machine. This machine is capable of either running on a physical or on a virtual mode. I'm not bothered. So it could either run on a physical machine or a virtual machine, but that single machine is termed as a node. You can run it on a kubeproxy, minikube, or kubelet. A kubelet is something that is considered to be a part of a cluster. Then we have something called the namespace. Namespace is a logical cluster, and this is for our understanding. It is a term logical, so physically you will not be able to see it, and this namespace is basically used for scoping access or dividing a cluster, and this is obviously for convenience purposes. This namespace is going to be widely used, and that is basically using this namespace, I will obviously be able to identify the clusters and group them as well. So after I have introduced you to the concepts or terminologies, now we move on into discussing about the Kubernetes architecture. The Kubernetes architecture, in short written as K8s, is divided into two parts. One is called the master node and the second part is called the worker node. Yeah. So we are basically dividing this architecture into two. The one is called the master node. The next one is called the a slave or worker node, whatever term you can call it. Yeah. So I call it as a worker node. You can even call it, or assume it to be a concept of what is called, a master and a slave concept. Also, it does the same job, Now, when you look into this architecture, you would probably understand certain things that are key here. Yeah, the first one, what you need to know is something called the API server. The API server is a part of the master here that you see, and this API server will be responsible for a single entry point into the master. In addition to the API server, I have cluster stores, the controller and the scheduler. So commands from the kubelet to the master are through, say for example, through a JSON file. There are other methods as well. Normally it is using a JSON file. And then you pass it on to the different nodes. The different nodes contain what are called the pods. And obviously we will see what it is. So when you look into the Kubernetes architecture, the first one which I am interested in to know is called the master node. Okay. So what is a master node? A master node is the most important component in the Kubernetes cluster. This master node is called the master because this is responsible for the management of the Kubernetes cluster. All administrative tasks gain entry through this point. There is no other way to gain access except through this master node. So you should always remember that you can have more than one master node in a cluster. Definitely this will help to achieve higher fault tolerance. So this master node has something called the API server, the control manager, the scheduler, the etcd, and all of these things. Looking into what is called the API server, this API server is an entry point for all commands that control the cluster. Yeah, so this is a single entry point, and this point will be basically responsible for looking at entry into the master. The next one, what I am interested in, is to look at what is called the scheduler. The scheduler, basically, as the term indicates, will schedule the tasks to the slave node. This scheduler basically stores all kinds of resource usage information for every slave node. I can call it as a worker node also, whatever. So this scheduler will take the responsibility of distributing the workload. So it will also help you to track the workload that is used on the cluster nodes. Yeah. So that is the basic job of a scheduler. So as the term indicates, the scheduler will be responsible for scheduling and allocating all kinds of pooled resources. So when you want the Kubernetes architecture to properly work properly, then obviously, the scheduler is important. Next, you have something called the etcd. The etcd components basically store the configuration details. I would say etcd is something like a configuration file. What does it do? This etcd will basically communicate with the several components. It will receive the commands and work. This etcd will also manage the network rules and the port forwarding activity. So etcd is important in a Kubernetes architecture because the etcd is nothing but a configuration file, and this configuration file is very, very important for all further communication with different parts of the Kubernetes. When you look at the worker node or the slave node, we call it, this node is equally important as the master, because all work from the master will be delegated to the worker or the slave nodes, and the slave and worker nodes are equally important. All the services will be managed by these nodes, and worker nodes will be able to do the jobs assigned. Then you have something called the kubelet. The kubelet will get the configuration of the pod from the API server. Please note this. I told you API server is a single entry, single exit point. And this kubelet will make sure that all the containers are up and running. Then you have something called the Docker container. The Docker container runs on every worker node, and it runs the configured pods. Then I have something called the kube proxy. This kube proxy is again important because this will serve as a load balancer. Then you have something called the pods, POD. This is a combination of single or multiple containers that run together on the nodes. So, looking at the Kubernetes architecture and the several parts that are key to the proper functioning of the Kubernetes, now what we would probably look at is, how a Docker and a Kubernetes probably distinguishes themselves. So with respect to scaling, Kubernetes have auto scaling feature. There is no auto scaling in a Docker. So all load balancing can be manually configured. Definitely, it's advantageous. A Docker does an auto load balancing. Probably a Docker reduces the job that is to be done manually. Then you have storage volume sharing. Kubernetes will share among multiple containers inside the same pod, whereas a Docker will share storage volumes with any other container. The logging and monitoring tool is inbuilt in Kubernetes. I need not bother about it. But when I look at a Docker, I probably need to depend on a third party application like Elk, probably, when I want to have some kind of a monitoring tool. Another key advantage of a Kubernetes over a Docker is, in case of the GUI, GUI is available for a Kubernetes but not available for a Docker. The installation might be easy and faster for a Docker, but it is obviously complicated and time consuming for a Kubernetes. When you look at what is called scalability, scaling up is slower, whereas scaling up is going to be much faster in a Docker. Then when you look at updates and rollbacks, only shared with containers in the same pod, whereas it is universal in the case of a Docker. So by looking at the key features of the Docker and the Kubernetes, and then how probably a Kubernetes varies from a Docker, what we would see now is some key advantages of the Kubernetes. In case of Kubernetes, it is easy to organize the service with pods. Another advantage of a Kubernetes is the company from which it comes. Kubernetes comes from the company called Google. This company has lots of years of valuable industry experience to the table. Kubernetes has a largest community among container orchestration tools. Kubernetes offers a variety of storage options, including storage area networks and public clouds, and obviously it adheres to the principles of immutable infrastructure. It also has certain other advantages like, Kubernetes can always run on premises on Google, Azure, Amazon Web Services, etc. It will avoid vendor lock issues. Containerization using Kubernetes will allow packages to serve these goals, and they also assures containerized applications to run when you want, where you want, and also it will help you to find resources and tools with which you will be obviously comfortable to work with. So, looking at the key advantages of Kubernetes, I will not say Kubernetes are always good. Kubernetes also comes with a very few disadvantages. The dashboard of Kubernetes is not as useful as it should be. Kubernetes is a bit complicated and unnecessary in environments. If you can probably do things locally, Kubernetes makes things a bit complicated. Another disadvantage of this Kubernetes is the security feature that is into the Kubernetes is not very effective. So looking at the advantages and disadvantages of Kubernetes, obviously Kubernetes advantages outweigh the disadvantages, and obviously you should always remember that any kind of a technology will have its pros and cons. So what we need to basically look at is, looking at your application, whether the technology will probably suit you the best or not, is what you need to look at before you choose the technology. So obviously Kubernetes offers a wide variety of applications which definitely will be useful, and definitely Kubernetes are powerful than a Docker and so on. So this concludes an overall introduction to Kubernetes.